thank Andrew Ritchie for the Brompton Bicycle. Super duper engineer, incredible brain, studied engineering at Cambridge, and probably his brain was so supreme that he was never going to work for someone else. He was always thinking outside the box, looking at things from a different perspective. He set off with various ventures, his friends helped him out, and sadly they didn't really take off.
This is where a rear frame starts. We start with a straight tube. That's the tube that we buy in. In this press we then bend it and then drill and deburr the hole, and that then forms the brake tube, which is part of the seat stay assembly.
Andrew visited the guys behind the Bickerton with his father's hope that he would get a proper 9-to-5 job. Andrew came back from the meeting, his dad asked him how did it go, and he said, oh, it was fantastic, oh, it was really interesting, but of course they haven't got a clue what they're doing it all wrong. I've got a far better idea, I'm going to do it myself. And his dad's like, oh no, I can't bear it. You know, he's gone off on another random trail. And that random trail started in 1975. He came up with this concept in his flat. It took him nearly 2 years, and in 1977 made his first prototype.
We're actually looking at the handlebar cell here. So the machine works with a rotary table. It's got 4 stations. The first station, the nozzles will heat the hinge to a temperature of about 900 degrees, at which point the braze ring which sits on top of the hinge melts and runs between the hinge and the tube. We'll then rotate around to the second station, where we just blow compressed air onto the part to gently cool the part down. The third station is water cooled, so it brings the part down to a handling temperature. And then we're back to the start where the parts are taken off.
So Andrew conceived a product. That is one thing. But then he went on not only to conceive the product, but to understand how to make it. And in fact, there's far, far more engineering in working out how to manufacture something, the jigs, fixtures, machines, than there is even in the product itself. I suppose, and that was a labour of love. I mean, thousands of drawings by hand, pencil, on paper, drawings by Andrew. What we've done as a team in the last 10 to 12 years is take that idea and apply modern engineering, apply finite element analysis, apply lean manufacturing, understanding best practice tools. In the UK, we're actually brilliant at making things very efficiently. We've got Nissan, we've got Triumph, we've got Jaguar Land Rover, we've got, you know, Henry Hoovers, and none of those companies will survive unless they are super efficient. So we didn't need to invent that. We just went out and learned and grabbed and took information everywhere we could. And because we are only making one product, we can obsess not only about the product, but about how we make the product. Every tiny detail, driving down error, right first time, minimum wastage.
My name is Joshua Bunker, and I'm a team leader for the production line. So what I do is I look after the line, make sure it's running and flowing the way it should be. Also, if there's any mistakes on the line, we repair them on the line. On the weekend shift, we go through 80 bikes a day, and during the week, it's 153. Yeah, there's been a lot of changes. The line never used to be here. We started off having individual bike builders, so the bike builders will get all the separate parts and build the bike themselves. So now it's come into a line, so it sort of have a piece of work each, and it all comes together at the end. So I think it's much more efficient now than it was, and it's also they're getting more bikes.
So every bike is made to order. This is what we call a pink, and that tells us how the bike is to be built. So all these codes here are all the options that are going on this bike. So the bike builder will pick this up, see what's going on, and then build it accordingly.
At Brompton, we make the humble folding bike. But what it does, it is not some carbon fibre, lycra-clad recreational thing that you bounce down a hill in once a month. This is a tool that people use in their lives every day to get around. And it tends to revolve around cities. It's in Barcelona, it's in New York, it's in Tokyo. It's popping up in cities around the world because it works. Now, interestingly, as a society, as a global society, people are migrating to cities. There is still net migration to cities. And there is something else that's happening to us. We are getting obese. We are not doing enough exercise. And governments don't have much money. They can't keep digging deeper tunnels under the city. They haven't got the money. And right under their nose is this simple little product called the bicycle, which is really part of the solution. And if you can make it fold, then it is that much more flexible, that much easier to fit into small flats, jump in the tube, jump on the bus, go out and explore the countryside. And then you start thinking about electric drive technology. Why are we stuffing electric drives into a 1-ton car to carry a 80-kilo human being? Stick the electric drive in a 10-kilo bicycle to carry an 80-kilo person. Now that's clever.
Within design and development at Brompton, we've got a few different teams. We look after product development, so we're taking the classic product, we're trying to make it better, more usable, lighter, nicer to use. We also work on the equipment, so we've got a team that look at the tooling that we use on the shop floor, whether that's a big thing like an automatic brazing machine or something small like a little check jig to allow us to get the quality we need. We do that as well. We also work on longer term, more strategic projects, so whether that's new materials to take weight out of the bicycle or looking at electronic systems and propulsion systems, we do that as well. So it's a pretty broad spectrum of stuff. I studied product design and manufacture. I left university 10 years ago, so it's a mechanical engineering degree. I'm a chartered engineer with the IMechE, and within the team we've got a mix of people, some that have come from industrial design backgrounds, but definitely the sort of technical end of the spectrum, some who've come from mechanical engineering but they're interested in design. We sort of tend to meet in the middle, but we're definitely an engineering company with an engineering ethos.
The potential for us as a company to innovate, to come up with new ideas, to use technologies that exist in different industries and apply them to our product means that there is a massive opportunity. And we have a British engineer who came up with a product to suck dirt off the floor. That is now a £1 billion business. We have something that improves people's lives in cities. We should be doing the same as Mr. Dyson, and in 20 years' time we should be talking here and say we have a £1 billion business changing transport in cities all over the world. Long way to go, but we'll get there step by step.